Okay, back after a little break. Here's part two. Continuing on with fish parts, we have bony fish have an operculum. This is the gill cover. Okay, which fish have them? We have bony fish will have them. So not your chondrichthyres, not your cartilage fish, not your agnathans, your jawless fish. Each of those have gill slits. The operculum is only found on bony fish. Location, this is their front flap. And the function is it protects their gills. Because just right on the other side are those bright red bloody gills. And they can open and close their opercula to help to create currents. So it helps to pull water in. They open up the flaps and it creates a suction to pull the water in. The lateral line function. These are pits that are found in between their scales, and this enables them to sense pressure waves. What I mean by pressure waves is I'm speaking right now and I'm creating a pressure wave that's running through the air, and you can hear that. So very similarly, these pits, they can sense vibrational movement from a distance away. So it's sort of like they're hearing. And so I'm going to say it's their hearing mechanism, but they don't really hear like we do. What they're really sensing is they sense motion from their surroundings. So they can school very quickly and respond to the schooling motion, or they can even respond to predators from a distance away. Coloration, many different types of coloration. So the first one is countershading. Countershading, we saw this in the tilapia with the darker top and the lighter bottom. So the top is darker. So we have a darker top and we have a lighter bottom of the fish. Cryptic coloration is to be cryptic is to be mysterious, secretive. And this is coloration that helps to camouflage. Disruptive coloration, this is when you see stripes or spots to disrupt the pattern of the fish. So you have stripes or spots. Iridophores, these provide iridescence or shininess, makes the fish shiny. We also have warning coloration, bright coloration. Bright colors to indicate that they're toxic. The theory of this is if they're a bright red or bright orange and they're eaten, well, they might get spit up after they've been eaten because the toxins have affected the creature that ate them. So that's not very helpful for that creature. However, it's helpful to the rest of the population because the creature that ate it will associate sickness with bright coloration, and it will avoid the bright coloration to not get sick. Air bladder and oil bladder. Both of these are for buoyancy. Okay, so the air bladders and pressure, size, location, and purpose. So the oil bladder, these guys are found in deep water. And then the air bladder, these guys are found near the surface. So their bladders can expand and contract to provide that buoyancy. And when you increase in depth, okay, you're going to be increasing in pressure. So increase in depth equals increase in pressure. And that's going to then squeeze the air bladder, making it smaller, making you less buoyant. It's going to make you sink more. So the air bladders are to compensate this. So increase the pressure, it decreases in size. So to increase the buoyancy, it'll inflate. So they inflate to increase the volume. And when you increase the volume, it's going to blow it back up again. That will then increase the buoyancy. Okay, so we talked about the pressure, the size according to the pressure. Purpose is to increase the buoyancy, and the location is it's usually found at the top of the abdomen. So it's right in the middle abdomen. It's right in the middle of the fish. And there are two types of fish, the Physoclistos and Physostomus. Here's a trick to remember the two, okay? Physoclistos, okay, this has the letters that almost you can rearrange to spell closed. C-L-O-S-T, closed, okay? So this is the closed bladder. And the Physostomus, okay, stomus, remember this little stomata, the little mouths that are found on the bottom sides of leaves, almost spells the word mouth, M-O-U-T, we're just missing an H. So this is the bladder mouth. And the pneumatic duct. The pneumatic duct is the structure in the Physostomus that connects the esophagus to the air bladder. So the pneumatic duct connects the esophagus to the air bladder. So this is found in the Physostomus. You have a pneumatic duct in the Physostomus. You do not have a pneumatic duct in a closed bladder. So in these guys, there's no connection. So there's no duct in the closed bladder. The bladder mouth has the pneumatic duct, and that is then going to connect. So we're drawing two quick pictures of this. Okay, here is the air bladder, there is the mouth and the esophagus. There's no connection. And then you have the Physostomus. Here's the mouth, here's the bladder. There's actually a little connection to get to the air bladder. That's the pneumatic duct right there. Okay, so this is the Clistos, and this is the stomus. Okay, this is the closed. This is where the pneumatic duct connects the bladder, which is right here, to the mouth. Okay, how can they change the size of the bladder? These guys can swallow air, and the air will go into their mouths, through the pneumatic duct, into their air bladders. They can also burp and fart. Burp, plus they can fart air. They can also draw air from their blood. Draw air from blood. Okay, so the closed bladder, they can't swallow air because it's not going to go into their bladder. They can't burp and fart air. It's not going to be any exchange between their bladder. But yes, we're going to put an arrow like this to indicate that that's the same thing. The only thing that the physoklistos can do is to pull oxygen from their blood and pump it into their air bladder. So a countercurrent exchange system in the gills, the structure and the benefit. Counter means against. So as the water comes in to the gill, your blood vessel is going to be going in the opposite direction. So blood meaning counter, counter meaning against. And we showed the two different systems of this. We did some numbers. The net effect of this, the countercurrent system in the gills, is that it absorbs more oxygen from the water. So it absorbs more O2 from the water. Reproduction, we have copulation versus spawning. Copulation is going to be internal. Spawning is going to be external. So most fish are spawning. There are sharks that actually have internal fertilization, if you remember the male claspers that we saw. So there's three types of births as well. You have your oviparous. Ovi means egg, parous means to give rise to, or birthing. They give birth to eggs. Okay, these guys are going to be the spawners. Or they can actually be the egg layers, like the egg cases. So sharks can have internal fertilization and lay egg cases. Ovoviviparous, ovo meaning egg, vivi meaning live, parous being birth. So they have internal eggs. They have internal eggs, but they give birth to live birth. So they develop on the inside, they're born live. So their eggs are not laid. Viviparous is no egg, and they just have a live birth. So those are all the multiple choice. Now we're going on to the short answer questions. Can you draw and name a Medusa and a polyp? So remember, Medusa is named after the Greek mythological character with the head, with the snakes. Okay, so this is the Medusa form of a cnidarian, and the polyp is going to be the upside down version of this, like an anemone. Anemone has the tentacles that face up like this. So you're going to have to know the name Medusa and polyp and to draw each of them. Flatworm, roundworm with motion, direction, and movement. Flatworms, okay, are flat. They have little cilia on their bottom ventral surface, and they move forward using the cilia. The roundworm, okay, they have more muscular development, and their muscles will contract alternatively, and they'll squiggle back and forth. So their muscles contract alternatively, meaning different parts, different sides. Muscles contract back and forth. When you contract, it will shorten this side, relaxing will lengthen that side, and then they'll alternatively have this whip-like motion. So they contract back and forth for whip-like movement or whip-like motion. Sketch and name the 3 body plan symmetries. So we've done this before with 3 different types. We have the asymmetry for the sponge. You have 2 openings like this. So here's a sponge, has all their in-current pore cells, one giant osculum for the excurrent of the water, but a sponge has asymmetry. You can then have radial symmetry, like the sea star with the pentaradial, or a jellyfish or other cnidarian, kind of top view with tentacles. Sea star or a jelly. And bilateral. Okay, shark, fish, okay, we did a lab looking at some clams. We also had a comparison of the adductor size for each of the creatures, and also their foot size as well. So the adductor size, the adductors, this is a white muscle that's used to open and close the shells. So these open and close their valves or their shells. So for mussels, their adductors were very, very small. The scallops were very, very large. Clams were about a medium size. Okay, why? The movement. The scallops have one large adductor muscle that's used to open and close their shell very quickly. They can clap their shells for motion. The clam is not using its adductors to swim. It has a burrowing lifestyle. So it just needs to use those muscles to open up. It has a very, very large foot. So these guys burrow. So they have a very large foot compared to the other groups. because this is what's being used for motion, not the adductor muscles. Muscles are attached, so they don't even move at all. So they have very small adductor muscles because they're not going to be opening and closing their shells. Draw the front side of a fish with counter shading and how it works. So here's the fish, here's the dorsal fin. Okay, we'll draw some pectoral fins. Okay, some eyes, mouth. Okay, remember the top side is a little bit darker. And the reason why is when you're looking from above, the watercolor or water intensity is darker down below. So what you would see with your eye is dark against dark. But if you're looking from below, you would see a light underside against a light backdrop because it's sunnier up above. Siphon and mantle and jet propulsion. So we did the squid dissection and we were able to see the siphon. This is like a straw-like structure. So the siphon is straw-like, it's just a little tube. And they use their mantle. Their mantle is that outer protective covering of the squid, of the octopus. And the mantle, it opens the mantle, opens up, so they open up a portion of their mantle. It opens up to pull water in. And then it closes the mantle and it squirts the water out through the siphon. Water squeezed through that siphon. So as it gets squeezed through the siphon, it's going to shoot the water out one way and the creature will go the other way. This, of course, is in the cephalopods. Two sea cucumber defenses. They have toxic threads, so they can shoot out toxic threads from the anus. They also have their spines or these plates inside their skin, which makes their skin very, very tough. They belong to the echinoderms. So the plates are inside the skin. There's a third one, I think we may have talked about this one as well. They can also vomit all their intestines. So you can know two of those three if you'd like. Herbivory and predatory gastropod radulas. They both have radulas, but the herbivorous ones have a cat-like scraping tongue. And the predatory ones have a proboscis. The proboscis, if you remember, probe means to touch, scissors means to cut. This is a spear-like structure. Your extra credit will be cyphozoans and hydrozoan body plans. So again, your cyphozoans, these are like your jellies. Your hydrozoans, these are like the Portuguese man of war. I don't know if I spelled that right. Portuguese man of war. So these guys have medusa, and they reproduce. That forms this polyp on the bottom of the ocean. Those will break off to become the medusa again. Portuguese man of war is actually a colony of polyps, and they have these sexual polyps that will produce very, very teeny microscopic medusa that will reproduce. There's no bottom of the ocean floor polyp form though. Those medusa that reproduce, the egg and the sperm, will grow back into a polyp, a floating polyp, and that will grow into your colony. So I'll let you look at your notes for that extra credit project there, and we're done.